Hello, class. Today we're going to be looking at rotations, and we're going to be also having a look at finishing up with basically all the transformation topics tomorrow with reflections and things like that. All right. So first things first is we're going to go ahead and work on this warm up. Give it a pause if you need to, and then we'll go from. Don't mind that. It's just coughing off somewhere since I noticed I had a little button going. So sorry about that. So we're going to write the composition of transformations as one transformation. Notice that we have three. Remember it said that it can be three or more. So that's just something to think about. We have 1, -1, 4, -2, and 3, -3, 5. So if we just add those together, 1 plus 4, subtract 3. 4 minus 3, well that's 1, plus 1 is 2. 5 minus 3 is 1 plus -1 plus -2 is -3. Gets to 2 as well. So just combine those and we get to 2. Okay. Now, if we're looking at it this way, what else we can say is a simple transformation. Anyways, today we're going to be dealing with rotations. We're going to rotate figures about and write rules for that. And you can say we spin things right round, just as an old song. And here's what we're doing today. We're going to have a look at the vocabulary, and we're then going to have a look at the discussion. Mind the noise in the background. Sorry about that. We'll wait for it to be over. Okay. We're going to be looking at vocabulary, and then we're going to have a discussion. Have about a visual presentation, a couple of graphs, common rotations without the graphs, and then go from there. So the review vocabulary we should have is angle of rotation. You should have seen this in the past, but it's okay if you haven't. Center of rotation, and just rotation in general. For rotation in general, we have basically the degree and the point. At times, it can be interchangeable. Some of those can be a little bit different at times, but it always has the degree point kind of situation. And something you should realize is that rotation is a rigid motion, so length and angle measure are preserved, and note that rotation is counterclockwise for positive angle measure. In this book, we use lowercase r, but normally it would be a capital R. So if we have a negative rotation, watch what happens. For a positive rotation, we have it going this way. Sorry. Positive rotation goes counterclockwise or anti-clockwise if you're from England, while a negative angle rotation is clockwise. So that's something you want to be familiar with. Something else you should note is that 90, 180, and 270 will be all we're dealing with. The higher any other degree will be more uncommon, and you'll probably have to use protractor to figure that out. And it might be used in other math classes. Okay. So, if we're going to rotate polygon A, B, C, D 90 degrees about the origin, so remember, since it's 90 degrees, we're going to go counterclockwise. In other words, we're expecting this D term to end down here, A, B term to end over here, and C term to end up here. So let's watch what actually happens. A moves over there, and we'll have a look at what the points are here in a second. B moves over here, moves to right there. C to right there, and D moves down into the third quadrant, or first quadrant. Now let's look at these and have a look. Notice that D is at -4, so let's put that down. We're at a -4, -2. It started out as a -2, 4. So that should give you a hint about what we did, -2, 4. So what did we do? We went from -2, +4 to -4, 2. So all we really did was swap the coordinates and take the opposite of whatever the first one was. Let's have a look at this one. We're going to rotate the triangle ABCD, -90 degrees about the origin. Or rotate a -90 origin, ABC. So we want to think about the process. Well, if we're going -90, that tells us we want to go in a clockwise direction. So let's just go see with one example what point will look like. So by moving the -1 to 1, we realize that we just, by moving it over to 1, it's kind of like a reflection in a way. So let's just move the entire shape this time. Grab the shape and move it. So notice that the entire shape just rotated by 90 degrees. So we went from here down to here. We went from a -1,5 to a +5,1. So what did we do? For -90 degrees, also known as 270 degrees, +270, we just, again, swapped the two numbers, y and x, and took the opposite of the second one of this time. So give it a pause and try to figure this one out. Where do you think this will go? We're rotating 90 degrees, and we're about the origin, and we're looking at W. So it could end up as 1, 2, 3, or 4. And the point we're looking at is this -8,7. So, welcome back. If you thought 4 or 2 would be the natural choices, but let's see between those two which one it should be. Comes down, goes back up. So we're looking at that 4. Or that 7, -8. So all we did was swap these two, and then took the opposite of the first. These are the common rotations as you've seen on the one handout that you should have at this point. And basically what you should be looking at is these are pretty easy to remember. Things to note about this slide at least is 270 degrees clockwise is the same as a -90, and 270 counterclockwise is the same as clockwise. You'll see that on the notes as well. Okay, so if you're looking at the graphless example, we have the vertices of x, y, z. It's -4, 7, 0, 8, and 2, -1. If we're rotating 180 degrees, what are we going to be doing? Well, we look at that, we match it with that, and just perform that operation. So -4, 7, we're just going to swap the two signs, make it 4, -7. 0, 8 will become 0, -8. And we forgot to put the little pride symbol. Z which is 2, -1, will become -2, +1. So all we really did was swap the two signs. Pretty simple. Okay. So go ahead and give this a pause and try to figure out which one we're looking at with this. So again, the question is, what are the vertices of a rotation of 270 degrees about the origin of what x, y, z, when x is -4, 7, y is 0, 8, and z is 2, -1. So 270, that is our clue. And remember, clockwise. So give it a pause, give it a go, give it a shot. Welcome back. Well, since you've come back at this point, all you really need to do is start with the very first point and see which one's matched. Notice there is none of the above, so it's going to be one of these. So we're looking at -4, 7, and we switcheroo that around. We'll have a 7, -4, and we need to take the opposite of the second one. So we're looking for our positive of 4. That's gone, so it has to be 3. So we just swap the points and apply negative to the second value. Pretty straightforward. All right, let's jump over to the OneNote. So this is the notes for today. And there was an edit I had to make to all of them, and we'll do that right now along on this one as well. On what I did with that, there it is. So there's a simple edit that we have to do. You should be edited on your document already, but it's right here. that one should read negative x, negative y. I'm in the wrong period, so let me fix that. Give me a second. Okay, here we are. So that one right there should read negative x, negative y. It's a simple error. I'll have to fix that myself. Okay, so we have a couple of examples. We have a rotation about the origin of 270 degrees of this shape, AB. So we should have the AB as well. Not a little mistake that I made. So what we're going to do is simply have a look at the shape and rotate it by 270 degrees. We can just look at our guideline. Our guideline up here says a negative 270 is simply a swap of the two and take the opposite of the first. So we see that B is at a 1, 1. A is at an 8, 6. Okay. So swapping 1, 1 turns into a negative 1, 1. And our B prime. 8, 6 becomes 6, 8. Take the opposite of the first. And we get a negative 6, positive 8. Negative 6, positive 8. Will put us right about there. And that is A prime. So that's, whoa, got a mind of its own there for a second. So as you see, we just grab a straight edge and draw that on in. So we'll grab one and make that a better line. Okay. So what you see with a rotation, it's not exactly a reflection. The whole thing is just kind of rotating. So that's something you want to pay attention to as well. The other thing you have is you have a polygon. You don't need to graph this one. If you have a polygon here, and we're rotating by 270 degrees, we kind of look at what our guideline says. So rotating of 270 degrees, counterclockwise. So we look up here, counterclockwise 270 is this one. So we take the y, negative x. So we can even write down that as our rule. So we can say, hey, we are going to take x, y, and that's going to become y, negative x. Okay. So for A, we have 10, negative 2. That becomes negative 2, 10. But the rule says we need to take the opposite of the second one. And that's all we need to do. So this is our A prime. B is at 5, 3. We swap the two, 3, 5. And our B prime, we need to take the opposite of the second one. C, negative 5, 6. The rule states we swap and take the opposite of the second one. So now that becomes a positive 5. D, swap and take the opposite of the second one. Another positive case. E, swap, and take the opposite of the second one. And then we're done. So that's why we kind of have this as a guideline in a sense. Okay. So at this point, you have another handout that's going to be coming to you if you're in class, and that's what we're supposed to be doing. But let's just go and go through the rest of these and fix out some of the more of these little mistakes I've made. A, B, C, D, rotate polygons. So yeah. So while it's being handed out, we can go through the rest of these. If we're rotating about negative 180 is the same as 180. They're both interchangeable. So we can just say that all we need to do is for xy is take a negative x, negative y. That's all we need to do. Okay? So if we're looking at C, C is right now, so right here, is at a 3, 4. B is at a 3, 6. A is at 5, 6. B is at 5, 4. So we have those points. So now we just need to take the opposites of those and follow the rule. So the new C will be at negative 3, negative 4. So negative 3, negative 4, and where they intersect. D will be at negative 3, negative 6, negative 3, negative 6. A will be at negative 5, negative 6. And B will be at negative 5 and negative 4. And we simply draw the shape in. Done. Rotate polygon about 90 degrees. We can refer back to our basically guide for the 90 degrees. So we go look for 90 degrees, and that maps to negative y, negative x. So we have this whole thing going on. Or negative y comma x. So that's what we have for that one. So we'll still have to rotate A, so we can always write down on the side where our points are. A is at a 9. Sorry, not 9, 9 is 0, 9. B is at 3, 6. C is at 0, 2. D is at negative 3, 4. And E is at negative 4, 7. So we have the points. Now we just need to apply it. Swap the 2 and take the opposite. So 0, 9 becomes 9, 0. Take the opposite, negative 9, 0. 3, 6 becomes 6, 3. Take the opposite of the first, negative 6, positive 3. 0, 2 becomes 2, 0. Takes the opposite of the first, negative 2, 0. 3, negative 3, 4 becomes 4, negative 3, or negative 4, negative 3. By taking the opposite of the first. Negative 4, negative 7, 7, negative 4, negative 7, negative 4. And then we just play the game, connect the dots, like the old connect the dot game. And then you're done with that one. Okay, so we're going to have a look at these last two, and then you know what you have to do for the rest of the period. We're going to rotate the image about the origin clockwise by negative 90 degrees. So we look at our guide, and it says y negative x. So that is our guide for this one. So A, swap the two. This is just giving us like A prime, so we're going to swap the two. So we're going to have a negative 2, 0, because we can't take the opposite of 0. So it's going to be negative, let's redo that slightly, negative 1, 1, but we need to take the opposite of that, 1. C, negative 3, negative 3, that doesn't change at all because they're both the same point, but we just still take the opposite of the second one, so that turns into a positive 3 on the backside. D, negative 7, negative 5, take the opposite of the second one, positive 5. Done. Wait, sorry, I forgot that E. 8, negative 2, take the opposite of the second one, and you're done. One last one to look at is 180. So the 180, the rule, if we go up and look at that, 180 and negative 180 are the same. So we have the x, y becomes a negative x, negative y. So all we need to do is just take the opposite of both. So a prime, we have 1, 4, negative 1, negative 4. B prime becomes a 1, negative 2. C prime becomes positive 3, positive 4. D prime becomes negative 2, positive 2. You're done. All right.